Now let us understand about it here. So wait a minute, let me tell you. Yeah, this one. Let's start with 10 by 3. Okay, it's 10 by 3, and if you'll divide it, you'll be getting the answer as 3.3333. It will never stop. It means it is endless. It is endless. And if a number is repeating again and again, what we do is make a bar on the number which is repeating. So you can see 3.3333, it's repeating again and again, and the remainder keeps on 1 1 1 1 and so on. The divisor here is 3. Then we are having an example of 7 by 8. If we'll divide it, we'll be getting answer as 0.875. So you have seen here, it is not endless, it is ended at a point of time. And the remainders here are 6, 4 and 0. The divisor here is 8. Then we are having example 1 by 7. And if we'll divide, we'll be getting the answer as 0.14285 and so on. So if we know, so this is also what? Endless. Matlab it has no ending point. So here what can we conquer? What can you conclude here is 0.14285 bar. It will repeat the same number of digits are gonna repeat at the time. So the remainders, if you'll notice here, the remainders here are 3, 2, 6, 4, 5, 1, again 3, 2, 6, 4, 5, 1 and so on. So what have you noticed here? You should have noticed at least 3 things. Let us start from here. Yeah. So the remainders either become 0 after certain stage or start repeating themselves. See, here the remainders start repeating. You may see here the remainders are getting repeated. And in this example, at the extent of time, the remainder has become 0. 0. The number of entries in the repeating string of remainder is less than the divisor. So, say in this 10 by 3, one number repeats itself and the divisor is 3. In 1 by 7, there are 6 entries. 3, 2, 6, 4, 5, 1 in the repeating string of remainders, and 7 is the divisor. If the remainders repeat, then we get a repeating block of digits in the quotient. For 10 by 3, 3 repeats in the quotient, and for 1 by 7, we get the repeating block of 142857 in the quotient. It will continue so on. Although we have noticed this pattern using only the examples above, it is quite true for all rationals of the form p by q where q is not equals to 0. On division of p by q, two main things happen. Either the remainder becomes 0 or never becomes 0, and we get a repeating string of remainders. Let's look at each case separately. So here we are having three cases. So in the first case, let me change the color. In the first case, the remainder becomes 0. So remainder becomes 0 at the extent of time. In the example of, let's say, 7 by 8, we found that the remainder becomes 0 after some steps, and the decimal expansion of 7 by 8 is equals to 0.875. Other examples are 1 by 2, or let's take a big number, 639 by 250. In all these cases, the decimal expansion terminates or ends after a finite number of steps. We call the decimal expansion of such numbers terminating. So if the decimal is getting end, we call it as terminating decimal means it stops. Then the second case we are having that the remainder never becomes 0. So what can we say here is it is endless. It is not ending. See, in examples 10 by 3 and 1 by 7, we notice that the remainders repeat after a certain stage, forcing the decimal expansion to go on forever. In other words, we have a repeating block of digits in the quotient. We say that this expansion is non-terminating, recurring. For example, 10 by 3. 10 by 3. So the answer is 3.333 and so on. It repeats. So the usual way of showing that 3 repeats in the quotient of 10 by 3 is to write it as 3.3 bar, as I told you earlier. So where the bar above the digits indicate the block of digits that repeats. So all these examples give us non-terminating recurring decimal expansion. So this is what known as that was terminating. Now this is non-terminating. Terminating means ending, and non-terminating means not ending. So non-terminating recurring, or non-terminating but repeating. Recurring means repeating, reoccurring. Thus, we see that the decimal expansion of rational numbers have only two choices: either they are terminating or non-terminating, recurring. Now, suppose on the other hand, on your walk on the number line, you come across a number like 3.142678 whose decimal expansion is terminating, or a number like 1.27, 1.272727, that is 1.27 ka bar, whose decimal expansion is non-terminating, recurring. Can you conclude that it is a rational number? The answer is yes. So, rational number. Now from here you will be getting what exactly is rational number. So we have told कि rational numbers is any number which we can represent in the form p by q, where q is equal where q is never equals to 0 and both are co-prime. This is how we defined earlier. Now we can add one more thing. So rational number can be of two type. Matlab, if these cases are happening, then we can say it is a rational number. First, the rational number terminates, or the second case we are having is the rational number is non-terminating but it recurs, मतलब non-terminating recurring. Okay, so rational number is any number which is terminating or non-terminating but repeating, then hence we can say it is a rational number. So this was all about rational numbers. Let's have a quick recap. So we have seen a rational number with a few examples. For example, 10 by 3, and it is endless. It means it is 3.3 bar, which is non-terminating but recurring. 7 by 8 means 0.875. It stops at a certain stage. It means it is a rational number because it is terminating. And here 1 by 7 is 0.142857 bar. It means 142857 is repeating. So we can say it is also a rational number and it is non-terminating recurring rational number. Now we have seen the two cases. Rational number can either be terminating or non-terminating but recurring, or non-terminating but repeating. And here finally we have seen the final definition of rational number. Rational number is any number which can be written in the form p by q, where q is not equals to 0 and both are co-prime. Co-prime means both are in simplest form. And here it is not complete. We have to say and the decimal expansion of a rational number is terminating or non-terminating recurring. That's the final definition of a rational number. Thank you. Subscribe my channel for more such videos. Have a good day.